Okay, so I have my blog post open here because this kind of is a starting point how everything started. So in my previous video, which I guess I'll link to, I discussed how what I would like to do as part of like kind of a bigger streaming project is build out this video game. And if you ever um, watch any of Pirate Software's streams, you'll note that one of the things that he says a lot, Mr. Thor is quite good at talking about video games. He knows a lot about them. Um, so one of the things he says is you can't be too hung up on particular details, like um, maybe you're not good at art, for example, right? So you don't want to be too hung up on whether or not your art is looking, great, or you have like the best mechanics ever, things like that. What you want to try and do is just start getting some things down, lean into your strengths, and then you can figure out your weaknesses after or asynchronously. One of my weaknesses is art. I do not know how to do art. So my one of my strengths is being able to program mechanics. So that's what I'm going to do. I'm going to start with Zig and WebAssembly. Zig is very low level. I feel like with Zig, I can compile it to just about anything, and then I can negate my need to stick to a particular rendering engine of any kind. So with Zig in particular, let's say we take WebAssembly out for a moment, I could technically compile all my Zig functions into a text-based output, which means my game could be a MUD. MUD for the old school folks who've been around for a while, maybe for some of the new folks too. Um, the the idea behind a MUD is like you type in commands and then it's all text based. It tells you like move, west, right? And then it'll say you've entered into a, like literally through text, you've entered into a new room and in the far corner is a torch and all that stuff. Then the other thing I could do is I could take the exact same mechanics. I can move rooms, I can attack whatever it is that I want to do, and I can replace the text-based rendering with any other rendering engine I want, whether it be 3D or 2D or whatever. And with Zig, I can even, like, if I really wanted to go crazy, I could try running it on a small device, maybe like one of the older Raspberry Pis, just on purpose. I have newer Raspberry Pis. I'm going to get my hands on a 5, but I also have like a 2 and a 3. What if I ran it on one of those, compiled by Zig, and I just attempted to maybe build out some hardware based um, interface for the game? Anyways, I think it leaves me a lot of flexibility, and it's also a hard way to do the game. I have some experience with C and C++ and like C sharp, if you want to kind of put it on generally under the same umbrella. So I kind of know how to work around in the low level languages and flash chips on a hardware device and things like that. But I'm not an expert. Like I don't do it day in and day out. So this is going to be an interesting challenge. On top of that, my starting point is probably going to be DOM anyways. I'm not going to do text. I'm going to do DOM. I might do text for some other things. I don't know. But the reason why I want to do DOM is text is easy to get around particular problems that I don't want to get around. I don't have to worry about a lot of different things like the state of my UI when I'm in text mode. But I do have to worry about that when I'm in UI mode. Where's my menu? Is it currently showing up? How do I catch um, keyboard inputs or mouse inputs or controller inputs? Make sure nobody can do like use weird keyboard combinations or trigger weird mechanisms or things like that. So for me, the DOM presents a set of challenges that I want to overcome, not least of which, and I think the most important one, is performance. Typically, people fall onto Canvas, WebGL, and now WebGPU. And the reason they fall into those, they attach themselves to hardware GPU processing in order to run faster. And I want to avoid that. I want to go hard mode. I want to deal with pure DOM rendering. What happens when I have to deal with a 2D game that I want it to be dynamic and reasonably good looking? That's going to be an interesting challenge. Can I even get there? How is WebAssembly going to help me get there? So I've already started doing this. I have some Zig code which compiles to WebAssembly, and then you have to have associated JavaScript code to call on that WebAssembly code to execute functions for you, return values, and then JavaScript gets to take the value and do other things with it if that's what you want to do. So I have gone through a number of things here, a number of mechanisms, and kind of explained in this blog post my starting point. I'll show you what it looks like in here. Let me just, I was trying out Harpoon, so from the Primogen, so that's why. So here's what I have. I've got some really, really, really ugly playground type Zig code. I'm gonna stretch this out. Oops. Let's get this opened up. There we go. So what I've been doing is thinking about the entire game as a grid. And in a grid, for me, it's going to be 2D top down. So that makes it easy for a grid to play nice with it. And I can create worlds, like an entire world. And I can create maps or sections of worlds, or I can create worlds within worlds. Here's an example. I could just consider everything a world. You walk into someone's house, that is the world of that house. You exit the house and you're in town, it is the world of the town. And each world is a grid, and each grid has layers. The layers at the very bottom can start with something like grass, rocks, maybe it's a blank, whatever you want. Then a layer for NPCs, then a layer for movable or controllable characters, usually the primary character that you control. Then a layer maybe for some clouds over top, and then one more layer for some filters, maybe things like that. And then I might have a layer between the ground and the NPCs of blocked versus non-blocked grid areas. So I can, in an editor, I could literally just click on a square in a grid and it would set it as a blocked square. So no NPC and no movable character can walk over that square because it's blocked. So that's kind of where the grid's coming from. And you can see in here that I've begun by creating an array list. It's just an array of arrays based on the size that I set, the dimensions. I'm setting 32 by 32. I'm not getting into the details yet because this is just a light overview. And then I go and start filling in the grid with things like what should be drawn in this grid. If I have an entity or I have like, some particular type of thing that I need to draw, I decide what gets drawn into which grid. Is the grid a blocker? Is it not? Etc. Then I define some setup. I have a struct for an entity. That's one of my main structs. Some of these other structs are going to change, so I won't even bother going over them. Including their position, some move functions, and some initial world data. The thing that I added most recently is a JSON file, and the JSON file contains, I should do yes. So the JSON file contains an initial set of data. And this initial set of data defines, like, for example, your world data with a block, right? So there's a block there. The one that one that says 1, that's a block. I thought it was a 32 by 32 grid. I am wrong. It is a 4 by 4 grid. In any case, I've set up 2 entities, and I have some bytes. Now, this is another hard mode thing I'm doing. This byte array is literally an RGBA channel. It is red, green, blue, and alpha, and it represents 1 pixel of an image. And I'm going to store data about images that I want to draw on my grid in this format. I think there's a way to use this format to do two things. A, efficiently pass image data around instead of loading PNGs and JPEGs and doing translation stuff and whatever. I'm going to end up having to convert images into bytes to begin with. In order for JavaScript to access any amount of data in Zig through WebAssembly, you have to access memory. And memory is basically accessing data like this. So if I'm going to be stuck doing this anyways, why don't I just write a bunch of images as bytes? Then I can store them as, say, JSON files or other types of files and embed them as part of my Zig WebAssembly output, or just my any compiled Zig output. And if it's embedded, it means that I don't have to pass around additional image assets. I can pass around the entire Zig compilation, and it is a self-contained thing with all the assets in there. I could choose it to do it another way. I suspect for my purposes, since I'm mostly going to be doing this in 2D, passing around bytes to different rendering engines will probably be more efficient, because it just means that the data is already in a state that is worthy of being passed around. The issue will come when I need to generate new images or new assets, and how I'm going to use an engine to translate those new assets into this format embedded in the Zig and continue usage. Okay, so just continuing on with where I was, what I've done is started a general purpose allocator. The general purpose allocator is memory for the application. There are, I think there are at least 2 other options that I could have chosen for memory. One of them includes a more low level, I guess, memory management. If you create memory, you kind of have to release memory manually. You can shoot yourself in the foot quite easily that way. There is another one that is a bit more. I think it's safer. I think there's 3 levels. It's safer, safe-ish, and pretty much unsafe. Something along those lines. General purpose allocator is good enough for now. It's going to deal with assigning me a reasonable amount of memory and making sure that the memory gets cleared for me, so I don't have to worry about it too much. At these beginning phases, it's great because then I can focus on some other complex problems and then come back to memory efficiency afterwards. So with that, I've embedded the JSON file that we just went over. I've set up some functions that are exportable. These exportable functions are functions that I can then call from JavaScript. I will show you how. You can obviously put in code in the functions that state how the function should behave and what it should return, if anything. So you can see I have like some move functions. I pass in, either a player, the current player you're controlling, or some kind of artificial entity like an NPC. I move their position around. I make sure they're updated. Then at any point, you can get an entity or a player's position and health. You can get world data. You can get world size and height, things like that. So with that, this is what I have set up in JavaScript land in order to pull in the compiled Zig WebAssembly project, and then I run it on the browser. So I have to, first define what my imports are. So my imports are the equivalent of the exports that we just saw in the zig file. And I have to define just like it's kind of like the C header. You're defining what they are and what their parameters are. And once they're imported this way and they match, then you're going to be able to call it, and it's going to reach into the WebAssembly code and run that function. I then wrap these import functions, which I think is a terrible way to do it. It was just something I did when I got started, and it has since ballooned. I wrap all the functions into a game object, and then I can trust that if I want to add some additional functionality on top of what's in the WebAssembly code, I can do it here. In order to call any function in WebAssembly, you have to essentially ask WebAssembly where in the chunk of memory you have been allocated, where is this function? And WebAssembly will tell you it is in location whatever it is. And in JavaScript, you're going to have access to that memory, and you're going to say begin at this position where you've told me the function is. Now run the function and then return to me a value. Sometimes what you want to do is just get access to an existing value. So your function, like if I go back into in here, so world data, for example, okay? What you're literally doing here is returning an I32 and a 32-bit integer, which is cast as a pointer, no, sorry, as an integer from a pointer to the data. A pointer points to something like data, to the data where world data exists. And if you know the integer location of the data and you know its length, therefore its ending position, so it'd be starting position plus length, you can extract just the data. So even though these are functions, really what they're doing, they're not really doing anything like, you know, adding, multiplying, whatever. They're literally just giving you access. They're giving you the address or location where you need to look in the memory block in JavaScript to get your stuff. So this is how we call our actions in JavaScript, or sorry, our functions in JavaScript with WebAssembly. And we can do whatever we want with them. I have a bunch of stuff commented in and out. I have a little mini script that runs stuff automatically, etc. The other thing that that I have is an HTML file. And this HTML file creates the grid, the world grid. Add some borders so that it's easy to see what the grid looks like. And then I just put in some really basic art. Like it's literally just squares, colored squares. That's all. But you can see how this works with enough JavaScript in here to generate the grid and fill it in based on actions that are being taken in the game. I also have some level of resizability. The grid will resize, and the world coordinates and all the entities and their positions will resize based on the available view of your screen, which means if you have, say, a tablet or a phone that's just on the right edge of screen resolution and you swap between landscape and portrait mode, it's going to recalculate the width and height available of the world grid and render your elements appropriately in that grid. So if we want to see this in action, I'm going to start up the server. There we go. So I'm going to show off a few things here. Let's say I refresh. Will it work then? Yeah. Okay. That should be dynamic. That should have happened dynamically. I don't know why it didn't, but in any case, it does work if you refresh. So that's at least something. So the deal here is, well, first, I'm using WASD. I'm literally just moving a square around. That's it. This really is not that fancy. Okay. I'm going to move, whoops. I'm going to move my face. I'll go right down here. Okay, so let's have a look at what's going on with the application. So I want to look at the memory that exists in the WebAssembly code so that I can kind of like get into what the memory generally looks like. How do I do that again? Performance, WebXR. No? Okay, that's fine. Because what I can do. No, wait. There's a way for me to get the memory. I just don't remember off the top of my head. It would be Game.js, and I would go. Oh, right. That's how. That's how. Okay. There it is. It was staring me in the face. So this is how you can view the memory block coming in from WebAssembly. So you can see here that your memory block has a byte length, and you can convert this memory. Yes, you can convert this memory into different types of arrays. I won't get into all the different types of arrays and what they're useful for, and I wouldn't even know it off the top of my head. I would have to go look this up. But depending on the type depending on the type of operation you want to run, you're going to want to use different types of JavaScript arrays. You can see a few of them already here. Yeah, there's some already here, and I can convert to any one of these, and it'll give me array outputs based on that. Now, what happens is that I can do something like get. Can I even do get world data? I don't even remember if I have that. World data. There we go. That's what it is. So we want world data. Yeah. So if you remember this function call in our Zig file, it's going to return the pointer to the location of our world data in the memory. And there it is. And then if I get the length, 16. So if I do this as my starting point, and then my endpoint is this plus 16, and I look in one of these array buffers, probably just like uint8, I would probably just do that. Then what I can do is something like, you know what? I don't actually think I have this. I might have to save this for another stream. World data. Yeah, I don't have it. But what I should be able to do is chunk out that particular block of data and read it. And I can read all the values in it. Sometimes you have to convert those arrays into like UTF-8 if they contain strings. You can maintain their integer values if world data contains only integer values, or you can mix and match depending on the structure of your data. But this at least tells you where to look for your data, how to extract it via JavaScript, and then you can do whatever you need to do with it. Some of the things that I want to do in the next few videos, I need to clean up the Zig code. This Zig code is terrible. I'm one of those people who I jump in and I start with like the most imperfect way to tackle a problem that I can think of to get through a bunch of problems and see if the whole thing's going to generally fit into place. Then I can kind of tell which things belong in the bucket of need to be cleaned up versus which things need to fall in the bucket of that's going to be a problem I actually have to solve for real. It gives me a lay of the land. So now that I've got past a certain point, I feel ready to start cleaning up this zig code and making it cleaner and then using subsequent JavaScript code to ensure that pretty much that whole moving around uh, the square on the screen, and when you reload the page it re-renders properly based on your screen availability, those should not change. That functionality shouldn't break. If it breaks, I have cleaned the code incorrectly on the zig side. So that's going to be kind of my basis for whether I'm moving forward correctly or not. And then I'm going to work on some DOM stuff. How do I make the animations maybe just a little bit nicer? Just see if I can do that. I think probably a better initial use of DOM time is, can I render layers correctly? I have blocking here. Nope. So you can see I can't walk over that blue square. That blue square is blocked. That's what was in the JSON file where the number 1 was at the bottom right of that array of arrays. So I cannot walk over. There's nothing I can do, right? That's a layer. I want to add some more layers. And eventually, I think probably sooner rather than later, I should make a little engine, a little DOM based engine where I can load up a grid and I can take assets that I have them on the screen somewhere, and plop them into squares and manage my layers. Then export those assets out into bytes. Save it as a file somehow, and then I guess embed it into the zig file, compile it into WebAssembly, and then run my JavaScript off that. So that's kind of the plan. It is a bit crazy. The reason why it's a bit crazy is historically pure DOM based stuff does not have good performance. Nowadays, I suspect if you were smart about it and you use some good techniques, you could probably get some decent performance, if not really good performance, at least at a 2D level. What's nice too is that you get the benefits of the browser. If you ask people to use the same browser, they're going to get a pretty consistent result experience. Browsers have plug and play capabilities with things like controllers, VR headsets, other peripherals. They'll play audio. You know, they'll render. It's great for rendering menus. You can see the top here, the top 2 rows. Yeah, the top 2 rows. They have like this. They're off colored, right? That's where my menu is going. It's the beginnings of a menu. I literally call it top menu. So I could just go like, I don't know, menu 1, menu 2, whatever. So yeah, HTML DOM is really good if you want to create some menus, some UI over top of your game. So I'm going to try basically to have my cake and eat it too. Generally speaking, you shouldn't get very far with this. You should run into enough problems that this isn't feasible for a 2D game. Not a good one anyways. Some people might disagree. I think there are some people who do 2D games like this and have done it in the past and they like it a lot. So I'm feeling like maybe I can pull at least some of this off. But even if I can't, the whole point of this is to learn from it. Why did it fail if it fails? And what could we do better? And how do these problems and potential solutions apply to other aspects of web development, maybe not related to creating games, 2D games, but there may be a lot of overlap with other types of websites that you or I might be working on. Okay, that's it. I'm going to end it there. Study marker.